Hello and welcome to this video for Electropages. I'm your host, Robin Mitchell. Today we're here at PCIM in Nuremberg 2025 and it's been a fantastic event. Now I'm at the WeEn stand to look at some pretty interesting technology that's coming out. So without further ado, thank you for having us here at the stand today.
Good to see you again.
Just introduce you to the audience who you are and what you do.
My name is Markus Mosen and I'm the CEO of WeEn Semi, and we are here at the PCIM, a regular guest. We are here, I can say, in the last 10 years with the booth getting bigger. We are a relatively young company, original, a joint venture between NXP and a private equity company from China. Now we are an independent company, and so we are running now 10 years of standalone business in the power semiconductor industry.
Fantastic. And being an independent company now, it must be nice to have that freedom to be able to sort of do what you need to do to develop your product.
That's right. That's definitely the biggest advantage you have. You can direct the investments you want to do, and you're not depending on a big company's, say, allocation of resources and money.
And so it's good to start off with that help, but when you're ready to sort of take on the market as you want to, you need to get that independence and sort of do things yourself.
Yeah, that's right. Well, for example, automotive, NXP, of course, our former mother company was or is a successful company in the automotive arena, but totally different segments.
Yeah, embedded systems. It's not really focused on the power side of things.
Exactly. They are not interested in it, but they are successful in other areas, of course. So for us, power was always a little bit lagging behind until we became independent. And then we started also to move into automotive. Before that, we couldn't have done that. It's a little bit, say, from the quality expectation and requirements too risky if you do that and you don't have the capabilities to fulfill the requirements.
Now, PCIM is all about power. And as we all know, things like EVs, electric systems are all becoming the rage these days. So could you just go through what products you're featuring today at the show and the advances that you're making?
Well, basically what you can see is, if you're looking around, comparing to last year, we have more bigger products on the show, which we call modules. So basically that's what you see here, and you can see some of the modules are exhibited over there. So basically we are investing into modules, and the main reason why we're investing into modules with our own plant, which we have set up in, the opening was last year in 24 in August. So basically we are building these modules there, WeEn packs, B1, B2, but also we have the big one, and then the WeEn module packages, which is a little bit different. They are smaller, but they have more power inside. So, and why we do this is basically because we want to move with silicon carbide, into automotive and into renewable energy. In both cases, for the inverter-based solar stations, you need, for example, modules to drive this. So basically, that's what we're trying to do, and that's why that's what I said. In the beginning, we are now directing the investment into these areas where we believe we need to be in the future, and not future is actually already today, of course. Saying that, not all, you see here the voltage ranges, but not all automotive or e-vehicle maker are using silicon carbide. But that's one of the challenges you had, like in recent years, when there was I call it overcapacity. Lots of new fabs in Asia, in China, but not only China, but also huge investments, of course, in Europe into capacity for silicon carbide. And then the company which was the major, say, purchaser of silicon carbide MOSFETs, mainly from our competitors, because we are not ready at that time, they stopped or they reduced their usage of silicon because it's getting too expensive. And then for the small cars, which have a range of 200 kilometers, to be honest, you don't need it. You just need to, because range doesn't matter. For the city car, range does not really matter. But another topic is, of course, the speed, to improve the speed of charging. And that matters, of course, even if you have a city car.
And I think that's an interesting point to raise, because when electric cars were when they were being developed, when they were becoming more and more popular, you had a lot of people saying, oh, the range is not far enough, I'm not ready to buy one. But like you say, in Europe, especially like places like Germany and the UK, you don't need a car that has 500 miles. You need a car that can go 30 miles, charge quickly, and do so while you can sort of just park your car 5 minutes, get some fuel and go.
Yes.
And so, are you saying that your solutions are sort of trying to address that problem?
Yes, we believe we are actually supplying already for charger, like for the big charger stations, but also onboard charger in the car. So we have already solutions for this. And basically you can see here that you have already with the auto crate, the silicon carbide MOSFETs, the Schottky diodes with auto crate, and of course this one not yet auto crate, because if you know, the fab was opened 1 year ago. You have to have at least 1 year running
To prove that you've got the reliability.
any quality issue.
Which we all know is going to have the quality, but unfortunately the rules just say you have to basically wait
it's
for a
okay.
year. Yeah.
Now,
And so that oh right, okay, so that implies that you also manufacture your own wafers.
sorry.
You manufacture your own wafers.
Yes, we
fantastic.
do own wafers, but not for silicon carbide. We have not started the investment into the wafer because we believe there's sufficient supply, and we also believe it's a little bit tricky, but I think there's too much of investments in China, and we think that we will be able to buy cheap equipment soon. Let me call it like this.
Well, that makes sense, because if everybody else is pouring money into it, you can sort of sit back and wait for it to be developed and then jump in when you need the parts at the time when you need them. But could you just quickly go back to one thing I want to ask?
Yes.
So when you talked about the modules, you said these would be useful for things like microinverters or solar panel systems and renewable energies. When would an engineer choose to go for something more like a soldered solution on a PCB?
Well, this is the famous solution which was invented by Tesla, right? And they opened the patents because that's a policy what Tesla has. So everybody can do it if they can have the capability to do it, right? So we are working on this as well. And this is used from Tesla for their, I think in the beginning it was for the Y version or even for the 3 Series. For the 3 Series, not anymore. And they put like 48 of these in the sequence, which means you have a much better range. And that was the secret of the range improvement in Tesla versus the competitors.
And so these would be better for automotive solutions, these types of packages over these modules. And these modules for more like for applications that aren't vibrating, aren't moving
For
around.
a charger, for example, you have for the big charger.
So you could have on like
big
the side of your
power.
house.
Yes.
Yeah, exactly.
And this one you will put into the car. And then you have hybrid solutions. Some companies offer hybrid solution, like a silicon carbide MOSFET or Schottky, and then a IGBT together with a silicon carbide solution. That is cost efficient, right?
Getting the best of both. And I think that cost efficiency is quite important, because I've seen a lot of engineers who are quite concerned about the price of silicon carbide. So they might say something like, oh, it's twice the price of a typical device. But in reality, you're getting double the power, half the space, and you end up saving money in the long run.
That's also not the case anymore. What I can tell you, for example, when you talk about silicon carbide Schottky diode, we started 2011. We were selling in mass about 10 years ago, since 2014, 15. At that time, when we started to approach customers with silicon carbide, like in Taiwan customers, so you can imagine who that is, 50 cents per amp. Today is 5 cents.
5 cents per amp.
Yeah. So you're talking about a 10 amp.
So to me, it sounds like you're implying that engineers out there who are not switching over to silicon carbide for their applications because of price, they are highly misinformed.
It's still more expensive, right?
But I would say the benefits that you get from silicon carbide outweigh the increase in the price.
That's true. But still, it is about double if you compare it with a 10 amp 650 volt.
But again, it's half the size. It's more power.
Yes.
It's a less heat produced.
Yes.
And so all of that has to be considered in that cost. So again,
I think the price will come down further, and then it will get into more applications. In the past, it was mainly used in, let me say, 3 applications. The one was EV, including chargers, then renewable energy, and in particular solar, and then also in server power. And server power is still increasing.
That's going to be a big one, especially with the rise of AI and the fact that any energy savings that can be made in a data center en masse would have a massive effect on reducing bills, reducing AC requirements and everything else. So it'd be absolutely massive. So we've got some interesting stuff over there. I can see a wafer. Can we go down and have a look?
Yes, of course we can.
Because wafers are awesome.
Sorry.
So just go through what's going on here on this stand.
Well, the wafer is an 8-inch wafer for IGBT, And the production, of course, we are not doing ourselves as well. We have a foundry for this. Actually, we have several foundries for this. But we are selling IGBT diodes since, I think we started in selling in mass in 4 years ago, around that. So mainly we are going into, well, you see basically industrial, yes, that's true. But it basically where we sell this one is like, or we call it industrial, it's like aircon solution. And then you also do sell it into modules. So for example, you see all the, well, we have some IGBT modules which we sell, like this one is the tube, and also these bigger ones. So they go into different solution, industrial solution with higher power. But our main market in that moment is actually for, some people call it home, but I call it industrial because it's for the big aircon solutions.
It's a great question about modules, because I'm kind of curious about this. So why is it that engineers would prefer to use a replaceable module over a soldered option?
I think a replaceable module, you said?
Well, these ones here. So
It's always kind of a solution, right?
Oh, so it's more than just the die.
Yes,
Oh,
it's
so
not
also
only
got
one
other
die.
parts.
Yeah.
Right.
So
I
that's
see.
why you have a little system which will help you
Okay.
to
And so-
faster replace.
And so I'm guessing, will this include things like gate drivers and parts like that as well?
Exactly.
And so, right, it becomes a one solution straight in. You don't have to worry about how to drive those individual transistors.
In principle, yes.
In principle, maybe
We
not in
shouldn't say
practice.
like this, but in principle, yes.
But it's still reducing the complexity of the design. You don't have to go back straight to the drawing board. Oh, I've
Yes,
got to
you don't
design a
have to
whole
do that
new thing.
yourself.
And that's why you got
Yes.
these small modules. Now, I
Yes.
quite like
And
the
you
look
can
of these
address
modules.
higher power, no?
Of course.
Into, and these are also getting smaller and smaller, like you've seen the pack modules.
Back over there. Should we have a look at those?
Yeah, well, these are the big ones, right? So,
Got these ones here, right?
yes. So these
wow.
are the real big ones. Basically, the Saristor modules, which are like I think it's quite famous ones. No? So the original big modules which were produced from the same likes like Semicron and Infineon and so on.
Yeah.
That is the old technology, but still used.
But still
a lot.
valuable and still
Yes, and
usable.
viable. Yes.
It was like
That one here is, for example, a SiC wafer, silicon carbide wafer, but we don't put it in this. So not in these modules.
Oh wow, that's an incredible looking wafer.
Yeah.
Oh wow. So just before
That's just a 6-inch. No? So we do have another, that's 8-inch again, and the small 5 inches over there.
oh yeah, look at that.
Small 5. These are the Saristors. Well, here you see again the modules, right? So basically that's what we are doing. We do the assemblies. This one will be packed in and look like this.
Yeah.
So basically these are the modules we are doing, and also all the packages. And yes, here we have like the silicon 20 millimeters or 30 millimeters.
Yeah.
We call it 20 like those.
Yeah.
You basically put in the Cyristors with
Right.
bigger power. And there are even requirements for power over 1500, over 1600, which we can't do with our own fab. So there we need to find a solution how we address this in the future.
And that's going to be the future for WeEn.
Yes, maybe, hopefully. Say like this.
So just before we wrap this video up, I've got
Yeah.
one more question for you. For the audience who are watching this video, if they want to get involved with WeEn Solutions, what would you recommend that they do?
I think the best is, of course, that you have a quick access via the website page, and then you or LinkedIn, or those technical media where you find WeEn. We are present in all of those medias, but the best would be just try to get via the web page, and there you can actually send an email and request for information,
Fantastic.
or come to the PCIM.
Come to PCIM. I think that's a solution for the engineers out there.
Yes.
Thank you ever so much for having us today.
Thank you.
It's been fantastic. Thank you.
Thank you.